Determine if each of the graphs below is a function. Explain why or why not. So remember, a function is a relationship where each x value has only one y value. So I'm going to look here and I notice that each x value has only one y value. So yes, each x value has only one y value. For this one, I notice right away that it's not, because x equals 1 has two different y values. Here I see that x equals -1 has two different y values. So it's not a function. Solve the quadratic equations below by completing the square. Alright, so I notice that I have an x squared. I have -6 x's, so I'm going to split those up 3 and 3. So this is x minus 3 and x minus 3. So that means to have a complete square, I'm going to need 9 ones right here. I have -12 ones. So to get all the way up to 9 ones, I'm going to need to add 21. So I have x squared minus 6x minus 12 equals 0. I'm going to add 21 to both sides. And that will give me x squared minus 6x plus 9 equals 21. Now, this represents the inside of the square. I can rewrite it as the product. X minus 3 squared equals 21. Now to solve this, I can take the square root of both sides. So I get x minus 3 equals plus or minus 21, or the square root of 21, which is 4.58. Now I can split this into two equations. X minus 3 equals positive 4.58 and x minus 3 equals negative 4.58. So I get x equals 7.58 or x equals negative 1.58. Is that right? Negative 4.3, negative 4.5, maybe that's not right. 4.58 minus 3. Yeah, 1.58. Alright, for the second problem, first I need to get it equal to 0. So I'm going to subtract 4x from both sides. So I have x squared minus 4x minus 3 equals 0. So now to build my square, I've got an x squared. I've got 4 x's, so I'll build it 2 on each side. So that's going to be x minus 2 and x minus 2. So I know that I need 4 ones right here. And I have negative 3 ones. So to get all the way up to positive 4 ones, I need to add 7 to both sides. So my new equation is x squared minus 4x plus 4 equals 7. Now I can rewrite this as x minus 2 squared. And then to solve it, I take the square root. So I get x minus 2 equals plus or minus the square root of 7 is 2.65. Now I split it into two equations. X minus 2 equals negative 2.65 and x minus 2 equals positive 2.65. I add 2 to both sides and I get x equals negative 0.65 or x equals 4.65. Duncan is testing two types of memory chips, W and Z, for performance and reliability. He measures the energy used by each chip to store data. A lower energy score is good. It means the chip works more effectively. Make a combination histogram and box plot for each type of chip. Start with 129 and use intervals of 3 when creating your histogram. So if I start with my class sizes, if I have class and then frequency, if I'm going to start with 129, it's less than or equal to x less than or equal to 132. Then I go 132 less than or equal to x, just less than 135. Then 135 less than or equal to x less than 138. And then 138 less than or equal to x less than 141. So same thing over here. Class, frequency. So it'd be 129 to 132, 132 to 135, 135 to 138, and then 138 to 141. All right, so my x-axis is going to measure, he measures the energy. So this is going to be energy. And then I'm going to start with 129. So I can go by threes, 1, 2, 3. So this is 132, 1, 2, 3, 135, 1, 2, 3, 138, 1, 2, 3, 141. Same thing here. 129, 1, 2, 3, 132, 135, 138, 141. So now to create my actual frequency table, for the chip W in the first class, in between 129 and 132, I'm going to have 1, 2, let's see, 132 is not inclusive, so just 2. From 132 to 135, because I have the equal sign on 132, I'm going to count 1, 2, 3, 4, 5, 6. But there's no equal sign on 135, so I don't count 135. So then from 135, 1, 2, 3, 4, 5, 6. And then 0 there. So to create this, well, let me make my other table first. So 129 to 132 here would be 1, 2, 3, not including 132. Equal sign is right here, so we include 132 in the second class. 1, 2, 3, 4, 5, 6, 7, 8. And then 135 to 138 would be 1. And then 138 to 140 would be 2. So now I know that my y-axis needs to go up to 8, so I'll skip by 2's. 1, 2, 4, 5, 6, 7, 8. So 132 to 1, this is frequency. (129 to 132), the first one has 2. Second one has 6. The third one also has 6. And then the rest have 0. For this one, 1, 2, 3, 4, 5, 6, 7, 8. The first one has 3. The second one has 8. The third one has 1. And the fourth one has 2. Now to make the, just going to cross those off. To make the box plot, I need to find the median. So I'll cross with a different color. So the median is right here at 133.5. The median of chip Z is right here at 133. Now to find the quartiles, I'm going to cross, and remember we do use these two numbers. So the first quartile is 132, and then I cross here. The second one is 135. And 134. So when creating my box plot, I'm going to start with the minimum. The minimum here is 130. The median is 133.5. So 133 is right here. 133.5 is right there. The minimum is 132. I mean, Q1 is 132. Q3 is 135. So here's the box. And then the maximum is 137, which is right here. For chip Z, the minimum is 129. The median is 133. Q1 is 132. Q3 is 134. Oh no, it's right here. And the maximum is 140. So here's the box. Okay. Which chip should Duncan recommend to the company? Use your histogram and box plots to explain your answer. So remember, we want a lower energy score. So I noticed that chip W is consistently lower. They have all of their chips perform below 137. Chip Z has almost all of its chips below 137, except for 2. Right here. Chip Z also has a lower median and a lower third quartile than chip W. So I think that I would recommend chip Z. Because the median and Q3 are lower. So most of the data is lower. It only had 2 chips that were higher, or that were high. So I would recommend chip Z. You could also make an argument for chip W though, because these are more consistently low.